Reading practice about AutoCAD prepared by Hammad Al Khayari. Chapter 1, Introduction to AutoCAD 1.1. What is AutoCAD? AutoCAD is a computer-aided design (CAD) software application developed by Autodesk. It is widely used by architects, engineers, graphic designers, and other professionals for creating precise 2D and 3D drawings and models. AutoCAD allows users to draft and design structures, plans, and components with a high degree of accuracy and efficiency. Its powerful tools enable the creation of intricate designs, making it an essential tool in various industries such as architecture, engineering, construction, and manufacturing. 1.2 History of AutoCAD. AutoCAD was first released in December 1982 by Autodesk, founded by John Walker and a group of co-founders. It was one of the first CAD programs to run on personal computers, which allowed users to create designs without the need for expensive mainframe computers. The software rapidly gained popularity due to its ease of use and powerful capabilities. Over the years, AutoCAD has evolved through numerous versions, incorporating advancements in technology, user interface enhancements, and new features tailored to meet the needs of design professionals. Today, AutoCAD continues to be a leading CAD software, with regular updates and improvements to keep pace with industry standards. 1.3 Applications of AutoCAD. AutoCAD finds applications across various fields including architecture, used for drafting floor plans, elevations, and sections, as well as creating 3D models of buildings. Engineering, employed in mechanical design, electrical schematics, and civil engineering layouts. Manufacturing, utilized for creating detailed part designs and assembly drawings. Construction, aids in developing site plans, construction documents, and project documentation. Interior design, helps in planning space layout, furniture arrangement, and interior detailing. Graphic design, supports vector graphics creation and manipulation for logos and other visual elements. 1 Page 1.4 System requirements and installation. To run AutoCAD efficiently, users must ensure that their systems meet the minimum and recommended requirements. As of the latest versions, the general system requirements include operating system, Windows 10, 64-bit, or later, Mac OS Monterey or later for Mac users. Processor, 2.5 to 2.9 GHz processor, recommended, 3+ GHz. RAM, minimum of 8 GB, recommended, 16 GB or more. Graphics card, DirectX 11 capable graphics card with a minimum of 1 GB GPU with 29 GB/SEC bandwidth. Disk space, at least 7 GB of free disk space for installation. Display, 1920x1080 resolution with true color. Installation typically involves downloading the software from Autodesk's website or using installation media. Users must follow the on-screen instructions, which include entering a serial number and product key, if applicable, and customizing installation settings as required. 1.5 Overview of the user interface. The AutoCAD user interface is designed to facilitate ease of use and accessibility to powerful tools. Key components of the interface include command line, a text-based interface that allows users to input commands directly, offering a fast way to execute tasks. Ribbon, a toolbar at the top of the workspace that organizes tools and commands into tabs and panels for easy access. Tool palettes, customizable panels that provide quick access to frequently used tools, blocks, and design elements. Drawing area, the central workspace where users create and modify their drawings. Status bar, displays information about the current drawing state and offers quick access to settings like grid, snap, and object snaps. 2-page, navigation bar, provides tools to pan, zoom, and navigate through the drawing. Properties palette, displays and allows editing of properties of selected objects, enhancing precision in design adjustments. Understanding these components is crucial for new users to maximize their productivity and efficiency while working in AutoCAD. Chapter 2, Getting started. In this chapter, we will cover the fundamental aspects of working with drawings in your software. Whether you are creating something from scratch or editing an existing piece, understanding how to navigate your workspace and manage your files is essential. 2.1 Creating a new drawing. To create a new drawing, follow these steps. 1. Open the application, launch your drawing software. 2. Select New, from the main menu, click on File and then select New or use the shortcut, usually Ctrl+N. 3. Choose a template, if prompted, choose from available templates or select a blank canvas. 4. Set dimensions, specify the dimensions and orientation of your drawing as needed. 5. Start drawing, use the available tools to begin creating your drawing. Familiarize yourself with the toolbar to access shapes, lines, colors, and other essential tools. Number 2.2 Opening existing drawings. To open an existing drawing, follow these instructions. 3. Page 1. Open the application, launch your drawing software. 2. Access the Open dialog, click on File and then select Open or use the keyboard shortcut, usually Ctrl+O. 3. Locate your file, navigate through your directories to find the drawing you wish to open. 4. Select the file, click on the file to highlight it, then click Open or double-click the file. 5. Edit as needed. Once the drawing is open, you can make any necessary edits or adjustments. 2.3 Saving and exporting drawings. It's crucial to save your work regularly to avoid losing any progress. Here's how to save and export your drawings. Saving your drawing. 1. Save your work, click on File and select Save or use the shortcut, usually Ctrl+S. 2. Choose location. If it's the first time saving, select a location on your computer. 3. Name your file, enter a name for your drawing and click Save. Exporting your drawing. 1. Select Export, go to File, then select Export. 2. Choose Format, choose the desired file format, e.g., PNG, JPEG, PDF, SVG. 3. Set options, if applicable, adjust any export settings like resolution or quality. 4. Save the exported file, choose a location to save the exported file and click Export. 2.4 Understanding file formats. Different file formats serve various purposes. Here are some common formats you may encounter. 4. Page, DWG, a native file format for AutoCAD drawings, widely used in engineering and architecture. DXF, Drawing Exchange Format, a format that allows for data interoperability between software. SVG, Scalable Vector Graphics, ideal for web graphics due to its scalability without loss of quality. PNG/JPEG, raster formats best for images and presentations but may lose quality when scaled. PDF, portable document format, commonly used for sharing drawings while preserving layout and quality. Understanding these formats will help you choose the right one for your specific needs. 2.5 Customizing the workspace. Customizing your workspace can enhance your productivity and make the drawing process more comfortable. Here's how to do it. 1. Access workspace settings, look for View or Window in the main menu, and find options related to workspace settings. 2. Arrange toolbars, drag and drop toolbars to rearrange them according to your preferences. 3. Change color themes, if available. Adjust the color scheme to reduce eye strain or match your style. 4. Set shortcuts, customize keyboard shortcuts for frequently used tools to speed up your workflow. 5. Save your layout, once you have configured your workspace, save the layout for future use. By following these steps, you will be better equipped to create, manage, and customize your drawings effectively. In the next chapter, we will explore the various tools and techniques for drawing and editing. Chapter 3, Basic Drawing Tools. 5 page. In this chapter, we will explore the fundamental drawing tools commonly found in graphic design and drafting software. Mastery of these tools is essential for creating precise and effective designs. 3.1 Line and Polyline. The line tool is one of the most basic yet essential drawing tools. It allows you to create straight lines by specifying 2 endpoints. Lines can be used to outline shapes, create borders, or connect points in a design. How to use the line tool. 1. Select the line tool from the drawing toolbar. 2. Click at the starting point where you want the line to begin. 3. Drag the cursor to the endpoint and click again to finish the line. Polyline. A polyline is a series of connected line segments that can create complex shapes. Unlike a simple line, a polyline can consist of multiple straight segments that change direction. How to use the polyline tool? 1. Select the polyline tool from the drawing toolbar. 2. Click to create the first point. 3. Continue clicking to add points, creating segments between them. 4. To finish the polyline, either double-click or press the Enter key. 3.2 Circle and Arc. Circle. 6. Page. The Circle tool allows you to draw perfect circles by specifying a center point and a radius. Circles are fundamental in creating rounded shapes and can represent objects like wheels, buttons, or diagrams. How to use the Circle tool? 1. Select the Circle tool. 2. Click on the location for the center of the circle. 3. Drag the mouse outward and click again or enter a radius to define the size. Arc. An arc is a portion of a circle and is useful for creating curves. You can define an arc by specifying its start and end angles and the radius. How to use the Arc tool? 1. Select the Arc tool. 2. Click to set the starting point of the arc. 3. Click to set the end point of the arc. 4. Move the cursor to define the curvature and click to finalize the arc. 3.3 Rectangle and Polygon. Rectangle. The Rectangle tool allows you to create rectangular shapes by specifying 2 diagonal corners. Rectangles are versatile and used frequently in layouts. How to use the Rectangle tool? 1. Select the Rectangle tool. 2. Click to set one corner of the rectangle. 7. Page 3. Drag the mouse to the opposite corner and release to create the rectangle. Polygon. The Polygon tool allows you to create multi-sided shapes. You can specify the number of sides and the radius of the polygon. How to use the Polygon tool? 1. Select the Polygon tool. 2. Click to set the center point. 3. Specify the number of sides and the radius to create the polygon. 4. Click to finalize the shape. 3.4 Ellipse and Spline. Ellipse. The Ellipse tool enables you to draw oval shapes by specifying the center point and the horizontal and vertical radii. Ellipses are useful for creating rounded forms that are not perfectly circular. How to use the Ellipse tool? 1. Select the Ellipse tool. 2. Click to set the center of the ellipse. 3. Drag the mouse to define the horizontal and vertical radii, then release to create the ellipse. Spline. The Spline tool allows you to create smooth curves that can adapt to multiple control points. Splines are particularly useful for designing organic shapes. 8. Page. How to use the Spline tool? 1. Select the Spline tool. 2. Click to create control points that define the shape of the spline. 3. Adjust the control points as necessary to shape the curve. 4. Double-click to finish the spline. 3.5 Using the Draw toolbar. The Draw toolbar is an essential interface component that hosts all the basic drawing tools. Familiarity with the Draw toolbar will streamline your workflow and make it easier to access the tools you need. Features of the Draw toolbar: tool selection. Quickly switch between different drawing tools by clicking on their icons. Customization options. Many drawing tools offer properties like line thickness, color, and fill options that can be adjusted from the toolbar. Shortcut keys. Learning keyboard shortcuts associated with the Draw toolbar can significantly increase your efficiency. Tips for using the Draw toolbar: explore all available tools and their features to fully utilize the software's capabilities. Organize your workspace to keep the Draw toolbar accessible and visible. Practice using each tool to become comfortable with its functionality and options. By mastering these basic drawing tools, you will lay a strong foundation for more advanced techniques in graphic design and drafting. Experiment with each tool to understand its unique features and capabilities. 9-page Chapter 4, Editing Tools in AutoCAD. In this chapter, we will explore the various editing tools available in AutoCAD. These tools are essential for modifying and refining your designs, allowing for greater flexibility and precision. Understanding how to effectively utilize these tools will enhance your productivity and improve the overall quality of your drawings. 4.1 Move and Copy. Move. The Move command allows you to reposition objects in your drawing. To use the Move command, 1. Select the objects you want to move. 2. Right-click and choose Move from the context menu, or type move in the command line and press enter. 3. Specify a base point, the point from which you want to move the objects. 4. Then, specify the second point, the location where you want to place the objects. Copy. The copy command creates a duplicate of selected objects. To use the copy command, 1. Select the objects you wish to copy. 2. Right-click and select copy, or type copy in the command line and press enter. 3. Specify a base point for the copy. 4. Then, specify the second point to place the copy. Tips: you can use the Control key while dragging to create a temporary copy of an object. 10. Page: use the clipboard commands, cut, copy, paste, for more complex duplication tasks. 4.2 Rotate and scale. Rotate. The rotate command allows you to rotate objects around a specified base point. To use the rotate command, 1. Select the objects you want to rotate. 2. Right-click and choose rotate, or type rotate in the command line and press enter. 3. Specify a base point around which the objects will be rotated. 4. Enter an angle or use your mouse to specify the new position. Scale. The scale command enables you to change the size of objects proportionally. To use the scale command, 1. Select the objects you want to scale. 2. Right-click and choose scale, or type scale in the command line and press enter. 3. Specify a base point for the scale operation. 4. Enter a scale factor, e.g., 2 for doubling the size or 0.5 for halving it, or drag the mouse to the desired size. Tips: use the reference option in the scale command for more precise scaling based on specific dimensions. The rotate command can be combined with other commands for more complex transformations. 4.3 Trim and extend. Trim. The trim command allows you to cut objects to meet the edges of other objects. To use the trim command, 11. Page 1. Type trim in the command line and press enter. 2. Select the cutting edges, the objects you want to use as a boundary. 3. Press enter, then select the objects you want to trim. Extend. The extend command allows you to lengthen objects to meet the edges of other objects. To use the extend command, 1. Type extend in the command line and press enter. 2. Select the boundary edges, the objects you want to extend to. 3. Press enter, then select the objects you want to extend. Tips: use the fence option to select multiple objects for trimming or extending. Both commands can be used in combination to refine complex shapes. 4.4 Fillet and chamfer. Fillet. The fillet command creates a rounded corner between two objects. To use the fillet command, 1. Type fillet in the command line and press enter. 2. Specify the radius for the fillet. 3. Select the first object, then the second object to create the fillet. Chamfer. The chamfer command creates a beveled edge between two objects. To use the chamfer command, 1. Type chamfer in the command line and press enter. 2. Choose the chamfer distance options, from 2 distances or angle. 12. Page 3. Select the first object, then the second object to create the chamfer. Tips: use the polyline option to apply fillets or chamfers to polyline segments. You can set default fillet or chamfer values for quicker access. 4.5 Undo and redo functions. Undo. The undo command allows you to reverse the last action taken in your drawing. To use the undo command, 1. Click the undo button on the toolbar, or type U in the command line and press enter. 2. You can continue to press undo to reverse multiple actions. Redo. The redo command allows you to reinstate actions that have been undone. To use the redo command, 1. Click the redo button on the toolbar, or type R in the command line and press enter. 2. You can continue to press redo to reinstate multiple actions. Tips: use the undo and redo commands frequently to correct mistakes and refine your work. Familiarize yourself with the undo and redo history to manage actions efficiently. In conclusion, mastering these editing tools will significantly enhance your workflow in AutoCAD. Practice utilizing them in various scenarios to become proficient and efficient in your drafting and design processes. Chapter 5: Layers and Properties. 13. Page 5.1 Understanding layers. Layers are fundamental components in design and drafting software, allowing users to organize and manage different elements of a drawing. Each layer can hold specific types of information or objects, such as dimensions, text, or geometry, providing clarity and control over the visual representation of the project. By utilizing layers, users can isolate, hide, or display various components, facilitating easier editing and enhancing the overall workflow. Key concepts: definition of layers. Layers serve as organizational tools that separate different elements in a drawing. Purpose of layers: improve clarity, manage complexity, and streamline the drafting process. Common applications: architectural plans, engineering drawings, and technical illustrations. 5.2 Creating and managing layers. Creating and managing layers is essential for effective design work. Most software provides tools to create new layers, assign properties, and organize them within a layer manager. Steps to create a layer. 1. Access Layer Manager. Open the Layer Management tool in your software. 2. Create new layer. Click on the option to create a new layer. 3. Name the layer. Assign a descriptive name that reflects the layer's purpose, e.g., electrical, plumbing. 4. Set properties. Configure properties such as color, line type, and line weight for visibility and distinction. Managing layers. Layer visibility. Toggle on/off to show or hide specific layers in the drawing. Locking layers. Prevent modification of elements on a layer by locking it. Deleting layers. Remove layers that are no longer needed, ensuring to verify that no essential elements are lost. 14. PAGE 5.3 Layer Properties. Color, line type, line weight. Layer properties play a crucial role in the visual hierarchy and presentation of drawings. Each attribute can be adjusted to enhance clarity and communication. Layer properties. Color. Assign colors to layers to differentiate between various elements. For example, electrical components might be green while structural elements could be blue. Line type. Use different line types, e.g., solid, dashed, dotted, to represent various types of lines, such as construction lines versus hidden lines. Line weight. Adjust the thickness of lines to emphasize certain elements over others, helping to create a visual hierarchy in the drawing. Best practices for properties. Use a consistent color scheme across projects for uniformity. Ensure line types are intuitive and easily understood by all stakeholders. Maintain a balance between line weight variations to prevent clutter. 5.4 Using layer states. Layer states are predefined configurations of layer properties that can be saved and restored as needed. This feature is especially useful for complex drawings where different views or presentations are required. Managing layer states. 1. Saving layer states. Capture the current configuration of layers, including visibility, color, and other properties. 2. Restoring layer states. Quickly revert to previously saved configurations, streamlining the process of switching between different views or phases of the project. 3. Managing layer states. Organize layer states for easy access, ensuring that commonly used configurations are readily available. 15. PAGE benefits. Increased efficiency in managing complex drawings. Consistency across different projects by using standardized layer states. 5.5 Best practices for layer management. Effective layer management can significantly enhance workflow and reduce errors in the drafting process. Here are some best practices to consider. Best practices. 1. Establish a layer naming convention. Develop a standardized naming system to make layers easily identifiable and organized. 2. Limit the number of layers. Avoid clutter by only creating necessary layers. Too many layers can lead to confusion. 3. Regularly review layer usage. Periodically check and clean up unused layers to maintain an organized workspace. 4. Document layer standards. Create a reference guide for layer properties, naming conventions, and usage to ensure consistency among team members. 5. Utilize layer filters. Use layer filters to quickly find and manage layers based on specific criteria, improving efficiency in complex drawings. By adhering to these best practices, users can enhance their layer management skills, resulting in clearer, more organized drawings that facilitate collaboration and communication among team members. Chapter 6. Dimensioning and annotations. Dimensioning and annotations are crucial components of technical drawings and engineering documentation. They provide essential information about the size, shape, and features of objects, ensuring that designs are accurately understood and executed. This chapter delves into various aspects of dimensioning and annotations, including adding dimensions, managing styles, editing text, and utilizing tables. 16 PAGE 6.1 Adding dimensions. Adding dimensions to your drawings is essential for conveying measurements and specifications. Here are the basic steps involved in adding dimensions. Select the Dimension tool. Most CAD software features a dedicated dimensioning tool. Access it from the toolbar or menu. Choose the dimension type. Decide on the type of dimension you need: linear, angular, radial, etc. Select points. Click on the points you want to dimension. For linear dimensions, select the two endpoints. For angular dimensions, select the angles defining lines. Place the dimension line. After selecting the points, move the cursor to position the dimension line and click to place it. Adjust positioning. If necessary, move the dimension line for clarity and readability. Repeat as needed. Continue adding dimensions as required to fully define the drawing. 6.2 Dimension styles. Dimension styles control the appearance of dimensions, including text size, line type, arrowheads, and more. Properly managing these styles helps maintain consistency across your drawings. Key elements include creating new styles. Most CAD programs allow you to create custom dimension styles tailored to your project needs. 17 PAGE Editing existing styles. You can modify existing styles to better fit your design requirements. This includes changing font sizes, line weights, and arrow types. Applying styles. Once you have defined your styles, apply them to your dimensions to ensure uniformity. Default settings. Set a default dimension style for new drawings to streamline your workflow. 6.3 Text styles and text editing. Text annotations play a vital role in conveying information within technical drawings. Understanding text styles and editing techniques can enhance the clarity of your annotations. Text styles. Define the font, size, and formatting of text in your drawings. You can create multiple styles for different types of annotations. Inserting text. Use the text tool to insert annotations where needed. Position text carefully to avoid cluttering the drawing. Editing text. Modify text as necessary, including changing font styles, sizes, and alignment. Using blocks. For frequently used annotations, consider creating text blocks for easy insertion and consistency. 6.4 Leaders and multi-leaders. Leaders and multi-leaders are used to point out specific features or details in a drawing. They enhance communication by directing attention to particular elements. 18 PAGE Creating leaders. Use the leader tool to create a line that connects a note to a specific part of the drawing. Adjust the endpoint to ensure clarity. Multi-leaders. These allow for multiple text entries connected to a single leader line, useful for labeling complex features. Customizing appearance. Modify the appearance of leaders and multi-leaders, including line type, arrowheads, and text style. Positioning. Ensure leaders and multi-leaders are positioned to avoid overlap with other drawing elements for clear communication. 6.5 Working with tables. Tables are an effective way to organize and present data in your drawings. They can be used for parts lists, specifications, and other information. Creating tables. Most CAD software provides tools to create tables. Define the number of rows and columns based on your needs. Entering data. Click into each cell to enter relevant information. Ensure data is organized logically for easy reference. Formatting tables. Adjust the appearance of tables, including borders, shading, and text alignment. Linking tables to drawings. Some software allows you to link table data to drawing elements, automatically updating the table when changes occur. 19 PAGE By mastering these aspects of dimensioning and annotations, you can create clear, informative, and professional technical drawings that effectively communicate your design intent. Chapter 7. Blocks and Attributes 7.1 Creating blocks in many design and drafting applications. A block is a collection of objects that are combined into a single object. Blocks are useful for repeated elements in a drawing, such as furniture, fixtures, or any other components that appear multiple times. To create a block, follow these general steps. 1. Select objects. Choose the objects that you want to include in the block. 2. Define block. Use the block creation command, often called create block or similar, to initiate the block definition process. 3. Specify base point. Choose a base point for the block. This point will be used for insertion and should ideally be a logical reference point, e.g., a corner or center. 4. Name the block. Assign a name to the block for easy identification. 5. Save the block. Confirm the creation to save the block in the drawing file or, if applicable, in a designated block library. 7.2 Inserting and editing blocks. Once blocks are created, they can be inserted into the drawing as needed. Here's how to insert and edit blocks. Inserting blocks. 1. Select Insert command. Use the Insert Block command, which typically allows you to browse and select the block by name. 2. Specify insertion point. Click to place the block in the desired location or enter coordinates. 20 PAGE3. Scale and rotation. Optionally, specify the scale factor and rotation angle to adjust the block's size and orientation upon insertion. Editing blocks. 1. Edit block definition. Use the block editor command to modify the block itself, allowing changes to geometry, attributes, or dynamic features. 2. Explode block. If you need to make one-off changes, you can explode the block, which breaks it back into its original components. Note that this removes the block's properties. 3. Update blocks. Changes made to the block definition will automatically update all instances of that block in the drawing. 7.3 Understanding attributes. Attributes are custom data fields that can be attached to blocks. They allow users to input information such as part numbers, descriptions, or other relevant data. Here's how to work with attributes. 1. Define attributes. When creating a block, you can define attributes by selecting the Attribute Definition command. Specify the tag, name, prompt, what the user will see when entering data, and default value. 2. Insert attributes. When inserting a block with attributes, a dialog box will prompt for each attribute value. 3. Edit attribute values. You can edit attribute values directly in the drawing or through attribute edit commands. 7.4 Creating and managing dynamic blocks. Dynamic blocks add flexibility to traditional blocks by allowing changes to their shape, size, or other properties without having to create multiple versions of the same block. 1. Create dynamic blocks. Use the dynamic block editor to define parameters, like length and width, and actions, like stretch or rotate, that control how the block behaves. 2. Parameter definitions. Assign parameters to control aspects such as size or visibility. For example, you can create a parameter that allows a door block to open or close. 21 PAGE3. Action assignments. Link actions to the parameters. For example, if a length parameter is changed, an associated stretch action can adjust the block's geometry accordingly. 4. Manage dynamic blocks. Update dynamic blocks by modifying parameters or adding new actions as project requirements change. 7.5 Benefits of using blocks. Using blocks in your designs offers several advantages. Efficiency. Blocks save time by allowing repeated elements to be reused without redrawing. Consistency. Using the same block ensures uniformity in design elements throughout a project. Ease of updates. Changes made to a block are reflected in all instances, simplifying updates and revisions. Reduced file size. Blocks can decrease the overall file size of a drawing, as the software stores the block definition once rather than multiple times. Enhanced data management. Attributes associated with blocks facilitate better data management and reporting capabilities within the drawings. By leveraging blocks and attributes effectively, designers can streamline their workflow and improve the overall quality and consistency of their work. Chapter 8. 3D Modeling 8.1 Introduction to 3D Concepts. 3D modeling is the process of creating a three-dimensional representation of a physical object using specialized software. Unlike 2D drawings that only provide height and width, 3D models incorporate depth, allowing for a more realistic and comprehensive visualization. Key concepts in 3D modeling include 22 PAGE, vertices, edges, and faces, the building blocks of 3D models. Vertices are points in 3D space, edges are lines connecting two vertices, and faces are flat surfaces enclosed by edges. Mesh, a collection of vertices, edges, and faces that defines the shape of a 3D object. Coordinate systems. 3D models are typically created within a Cartesian coordinate system, defined by x, y, and z axes. Materials and textures. To enhance realism, 3D models can be applied with various materials and textures that simulate different surfaces and finishes. 8.2 Creating 3D objects. Creating 3D objects in AutoCAD involves several methods. Primitive shapes. Start by using basic geometric shapes, such as boxes, spheres, cylinders, and cones, which are the foundation of more complex models. Extrusion. This technique involves taking a 2D shape and extending it in the z-axis to create a three-dimensional form. Revolution. By rotating a 2D profile around an axis, you can create 3D objects like cylinders or toruses. Lofting. This method allows the creation of complex shapes by defining multiple cross-sections, which the software will interpolate between. Sweeping. A 2D shape can be moved along a predefined path to generate a 3D object. 8.3 Modifying 3D objects. Once 3D objects are created, they can be modified using various tools. Scaling. Change the size of an object uniformly or non-uniformly along specific axes. Rotating. Adjust the orientation of an object around its axis or a defined pivot point. Mirroring. Create a symmetrical counterpart of an object by reflecting it across a designated plane. Boolean operations. Combine or subtract 3D objects using union, subtraction, or intersection to create more complex shapes. 23 PAGE 8.4 Viewing in 3D. To effectively work with 3D models, it's crucial to understand different viewing techniques. Orbiting allows you to rotate around the model to view it from different angles. Panning. Move the view left, right, up, or down without changing the perspective. Zooming adjusts the distance to the model, allowing for detailed inspection or a broader view. Viewports. AutoCAD provides multiple viewports to display different angles or perspectives of the 3D model simultaneously. 8.5 Rendering. In AutoCAD, rendering is the process of generating a photorealistic image from a 3D model. In AutoCAD, rendering involves lighting, setting up different types of lights, e.g., point, directional, spot, to simulate how light interacts with the model. Materials. Applying realistic materials with properties such as color, texture, and reflectivity to enhance the visual quality. Camera settings. Adjusting the camera angle and focal length affects the final output and perspective. Render settings. Choosing the appropriate render quality and resolution impacts the detail and processing time of the final image. Post-processing. After rendering, further enhancements can be made using image editing software to fine-tune the visual presentation. By mastering these concepts and tools, users can create intricate and visually appealing 3D models in AutoCAD, suitable for various applications such as architecture, engineering, and product design. Chapter 9, Advanced Tools and Techniques. 24 PAGE. In this chapter, we will explore various advanced tools and techniques in AutoCAD that can enhance your productivity and streamline your workflow. These methods are particularly useful for experienced users who want to take full advantage of AutoCAD's capabilities. 9.1 Using the command line. The command line is one of the most powerful features in AutoCAD, providing quick access to various commands and tools. Understanding how to effectively use the command line can significantly speed up your drawing process. Key tips for using the command line: autocomplete. Start typing a command, and AutoCAD will suggest possible commands. This feature saves time and minimizes errors. Command history. Press the up and down arrows to navigate through previously entered commands. This is especially helpful for repeating commands. Dynamic input. Toggle dynamic input, F12, to display command prompts near your cursor, allowing you to see options without moving your eyes away from the drawing area. Keyboard shortcuts. Learn and use keyboard shortcuts for frequently used commands to enhance efficiency. 9.2 Custom commands and macros. Custom commands and macros can automate repetitive tasks, saving time and reducing the potential for errors. Creating custom commands. Use the CUI, Customize User Interface, editor to create new commands. You can assign a macro to a command button or define a command alias. Macros can be recorded or scripted using AutoLisp or VBA to perform a series of actions with a single command. 25 PAGE number example macro, Lisp, definc my macro, command line 0,0 100,000 100, command circle 50,50 25. This simple macro creates a line and a circle with defined coordinates. 9.3 Advanced editing techniques. Advanced editing techniques can help you manipulate objects more effectively and efficiently. Techniques to consider. Grips. Use object grips to stretch, move, or rotate objects quickly. Grips provide a visual way to edit without using commands. Dynamic blocks. Create dynamic blocks with parameters and actions that allow for variable sizes and configurations without needing multiple block definitions. Ecrefs. External references. Use ecrefs to manage large projects by linking external drawings. This allows multiple users to work on different parts of a project while maintaining a cohesive drawing. Object snaps. OSNAPs utilize object snaps to accurately select points on objects, ensuring precision when editing. 9.4 Using the Design Center. The Design Center is a powerful tool that allows you to manage and access various design elements, including blocks, styles, and layouts. Features of the Design Center. 26 PAGE. Browse and insert. Quickly browse and insert blocks from other drawings or libraries without needing to open each file. Styles management. Import and manage text styles, dimension styles, and other settings to maintain consistency across projects. Content libraries. Create and maintain libraries of frequently used components, making it easy to access and insert them into new drawings. 9.5 Customizing AutoCAD with scripts. Scripts are a great way to automate tasks in AutoCAD, particularly for repetitive processes. Creating and running scripts. A script is a plain text file with a .scr extension containing a series of AutoCAD commands. To create a script, write the commands in a text editor, one per line. Here's a simple example. Plain text line 0,0 100,000 100 circle 50,50 25. To run a script, use the script command in AutoCAD and select your script file. The commands will execute sequentially, speeding up your workflow. 27 PAGE Benefits of scripting. Automates repetitive tasks, reducing manual effort. Ensures consistency in command execution. Saves time when dealing with large projects or numerous drawings. By mastering these advanced tools and techniques, you can enhance your efficiency and effectiveness in AutoCAD, allowing you to tackle complex projects with ease. Chapter 10, Printing and Plotting in AutoCAD. In this chapter, we will explore the various aspects of printing and plotting in AutoCAD, ensuring that your designs are presented clearly and professionally. We'll cover the setup of print layouts, configuration of plotters, printing to PDF, managing page setups, and best practices for successful plotting. 10.1 Setting up print layouts. Setting up print layouts in AutoCAD is essential for producing accurate and professional-looking prints. Here are the steps to set up your print layout. 1. Switch to Layout tab. Open the Layout tab where you want to create your print layout. By default, AutoCAD provides a Layout 1 and Layout 2 tab. 2. Page Setup. Right-click on the Layout tab and select Page Setup Manager. In this window, you can create a new page setup or modify an existing one. 28 PAGE 3. Select Plotter. Choose the appropriate plotter from the list. If you're using a physical printer, select it here. For PDF output, select a PDF plotter. For paper size, specify the paper size based on your project requirements. Common sizes include A4, A3, and letter. 5. Plot area, define the plot area, e.g., limits, extents, window, to ensure the correct portion of your drawing is printed. 6. Scale, set the scale for the drawing. This is crucial for ensuring that dimensions are accurate on the printed page. 7. Orientation, choose between portrait or landscape orientation based on your design. 8. Margin settings, adjust the margins if necessary to ensure that important elements are not cut off during printing. 9. Save settings, after configuring the settings, save the page setup, and apply it to your layout. 10.2 Configuring plotters. Configuring plotters in AutoCAD is key to achieving high-quality prints. Follow these steps. 1. Access plotter configuration, go to the Output tab, and then click on Plot. 2. Select the plotter. In the Plot dialog box, select the plotter you wish to configure. If your plotter is not listed, you may need to create a new plotter configuration file, PC3. 3. Plotter properties, click on the Properties button to access the plotter settings. Here, you can adjust various parameters, including resolution, color settings, and paper handling. 29. PAGE4. Test print. Before finalizing, it's a good practice to perform a test print to verify that all settings are correct. 5. Save configuration, save your plotter configuration for future use, ensuring consistency across prints. 10.3 Printing to PDF. Printing to PDF is a convenient way to share your AutoCAD drawings. Here's how to do it. 1. Select PDF plotter. In the Plot dialog box, select a PDF plotter, e.g., DWG to PDF. 2. Configure settings. Follow the same steps as for configuring a physical plotter. Adjust settings such as quality, paper size, and scale. 3. File name and location. Specify the output file name and choose a location to save the PDF file. 4. Preview. Use the preview feature to ensure that the drawing appears as expected before finalizing the PDF. 5. Plot. Click the OK button to create the PDF. Check the output file to confirm that it meets your expectations. 10.4 Managing page setup. Effective management of page setups is vital for maintaining consistency across multiple drawings. Here's how to manage page setups. 1. Page Setup Manager. Access the Page Setup Manager from the Layout tab by right-clicking and selecting it. 30. PAGE2. Create and edit. Create new page setups or edit existing ones. This allows you to standardize settings across various layouts and drawings. 3. Set defaults. Consider setting a default page setup that can be used for new layouts. This ensures that every new layout begins with your preferred settings. 4. Import/export settings. You can also import or export page setups to share with team members or apply to different projects. 5. Organize layouts. Keep your layouts organized by naming them logically based on their purpose or content. 10.5 Best practices for plotting to ensure high-quality prints and efficient workflow. Consider the following best practices. 1. Check scale and units. Always verify the scale and units of your drawing before printing to avoid discrepancies. 2. Use layers wisely. Organize your drawing using layers, and control visibility to ensure that only relevant information is printed. Chapter 11. Collaboration and Sharing. 11.1 Using AutoCAD with other software. 31 PAGE. AutoCAD is a powerful tool that can integrate with various other software applications to enhance productivity and improve workflow. Users can leverage different platforms to complement AutoCAD's capabilities, such as BIM software, integrating AutoCAD with building information modeling, BIM. Tools like Revit allows for better visualization and coordination in construction projects. Project management tools. Software like Microsoft Project or Trello can be linked to manage timelines, track tasks, and assign responsibilities, ensuring that everyone is on the same page. CAD interoperability. AutoCAD supports various file formats, allowing users to import and export drawings from other CAD systems, such as SolidWorks, SketchUp, and others. Understanding how to effectively use AutoCAD alongside these applications can streamline processes and improve collaboration. 11.2 Importing and exporting data. AutoCAD allows users to import and export a variety of data formats, which is crucial for collaboration across teams and software platforms. Key aspects include file formats. AutoCAD supports numerous formats, including DWG, DXF, DGN, and PDF. Users can import these formats to work on existing projects or export their designs for use in other applications. Data integrity. When importing or exporting files, it's important to ensure that the data retains its integrity. Users should be aware of potential issues such as scaling, layer management, and object compatibility. Using data links, AutoCAD allows for external references, ecrefs, and data links to be established, enabling users to maintain a live connection to other documents or databases, which can be updated as changes occur. By effectively using these importing and exporting features, teams can enhance collaboration and ensure that all members have access to the most current data. 11.3 Collaboration tools in AutoCAD. 32 PAGE. AutoCAD offers several built-in collaboration tools that facilitate teamwork and project coordination. Shared views. This feature allows users to share their designs with others without needing to send the actual drawing file. Recipients can view and comment on the design in a web browser, leading to more effective feedback loops. Markup tools. Users can annotate and mark up drawings directly within AutoCAD, making it easy to share comments or suggestions with team members. Collaborative workspaces. AutoCAD enables teams to work simultaneously on a project through its cloud-based features, allowing for real-time collaboration and updates. By utilizing these collaboration tools, teams can improve communication and enhance the efficiency of their design processes. 11.4 Using cloud services. Cloud services play a significant role in modern design workflows, providing benefits such as accessibility. Cloud storage solutions, like Autodesk Drive or other third-party services, allow users to access their designs from anywhere, facilitating remote work and collaboration. Version control. Cloud services enable teams to manage different versions of a project easily, reducing the risk of working on outdated files and ensuring that everyone is using the latest version. Real-time collaboration. Features like AutoCAD's integration with Autodesk BIM 360 allow multiple users to work on the same project simultaneously, providing a seamless experience for teams spread across different locations. By leveraging cloud services, teams can enhance their collaborative efforts and improve overall project management. 11.5 Best practices for team collaboration. 33 PAGE. To maximize the effectiveness of collaboration in AutoCAD, consider the following best practices. Establish clear communication channels. Utilize tools like Slack or Microsoft Teams to ensure that all team members can communicate effectively and stay updated on project developments. Set up a standardized workflow. Create and document a workflow that all team members can follow, including naming conventions, layer management, and file organization. Consistency helps minimize confusion and errors. Regularly schedule check-ins. Hold regular meetings or check-ins to discuss progress, address challenges, and gather feedback. This keeps everyone aligned and fosters a collaborative environment. Encourage feedback and iteration. Foster a culture where team members feel comfortable providing feedback on designs. Iterative processes lead to better outcomes and more innovative solutions. By implementing these best practices, teams can improve their collaboration in AutoCAD, leading to more successful projects and enhanced productivity. Chapter 12. Troubleshooting and support in AutoCAD. 12.1 Common issues and solutions. AutoCAD users may encounter a variety of issues while using the software. Below are some common problems and their potential solutions. 12.1.1 Crashing or freezing. Solution: ensure your system meets the minimum requirements for running AutoCAD. Update your graphics drivers and check for software conflicts. If the problem persists, consider resetting AutoCAD to its default settings. 12.1.2 Slow performance. Solution: optimize the performance settings in AutoCAD. Close unnecessary background applications and reduce the complexity of the drawings. Use the purge command to remove unused items. 34 PAGE 12.1.3 Missing toolbars or panels. Solution: reset the workspace to the default setting by going to the workspace drop-down and selecting Reset. You can also check the CUI, Customize User Interface, to ensure toolbars are enabled. 12.1.4 Errors in drawing files. Solution: use the audit command to check and fix errors in the drawing file. If the file is corrupted, try recovering it with the recover command. 12.1.5 Licensing issues. Solution: verify your license status through Autodesk account. If there are issues with activation, try re-entering the serial number or contacting Autodesk support for assistance. 12.2 Accessing help resources. AutoCAD offers several resources to assist users in resolving issues. 12.2.1 Built-in help. Access the built-in help feature within AutoCAD by pressing F1 or navigating to the help menu. This provides documentation on various commands and features. 12.2.2 Online documentation. Autodesk maintains comprehensive online documentation, including user manuals, tutorials, and FAQs. Visit the Autodesk Knowledge Network for detailed articles and guides. 12.2.3 Video tutorials. YouTube and Autodesk's official website offer a range of video tutorials that can help users troubleshoot specific issues or learn new techniques. 12.3 AutoCAD Community and Forums. 35 PAGE Engaging with the AutoCAD community can provide valuable insights and solutions. 12.3.1 Autodesk Community Forums. Join the Autodesk Community Forums to ask questions, share experiences, and find solutions from other users and Autodesk experts. 12.3.2 Social media groups. Platforms like LinkedIn and Facebook have dedicated groups for AutoCAD users where you can connect with peers, share tips, and find support. 12.3.3 User groups. Consider joining local or online user groups that focus on AutoCAD. These groups often host events, webinars, and discussions that can enhance your skills and knowledge. 12.4 Keeping AutoCAD updated. Regular updates are crucial for optimal performance and security. 12.4.1 Automatic updates. Enable automatic updates in the Autodesk account settings to ensure you always have the latest features and fixes. 12.4.2 Manual updates. Check for updates manually by navigating to the Autodesk desktop app or the Autodesk account. Download and install any available patches or updates. 12.4.3 Release notes. Review the release notes for each update to understand new features, enhancements, and bug fixes. This information can help you make the most of the latest version. 36 PAGE 12.5 Contacting Autodesk support. If you encounter persistent issues that cannot be resolved through available resources, contacting Autodesk support may be necessary. 12.5.1 Support options. Autodesk offers various support options, including live chat, email support, and phone support. Check the Autodesk website for the most appropriate contact method based on your subscription level. 12.5.2 Preparing for support. Before reaching out to support, gather relevant information such as your product version, system specifications, and a detailed description of the issue. This will help expedite the troubleshooting process. 12.5.3 Support community. Utilize the Autodesk support community for additional help. Many users share their experiences and solutions, which can be beneficial for troubleshooting common problems. By familiarizing yourself with these troubleshooting and support resources, you can enhance your experience with AutoCAD and resolve issues more efficiently. Chapter 13, Tips and Tricks about AutoCAD. In this chapter, we will explore various tips and tricks that can enhance your productivity and efficiency while using AutoCAD. From keyboard shortcuts to customization options, these insights will help you streamline your workflow and make the most of this powerful design tool. 37 PAGE 13.1 Keyboard shortcuts. Keyboard shortcuts can significantly speed up your workflow in AutoCAD. Here are some essential shortcuts to remember: L, line, C, circle, R, rectangle, A, arc, E, erase, M, move, CO, copy, RO, rotate, SC, scale, X, explode, Z, zoom, D, dimension, H, hatch, Ctrl plus Z, undo, Ctrl plus Y, redo. You can also create custom shortcuts for commands you use frequently by using the CUI, Customize User Interface, command. 13.2 Customization Tips. 38 PAGE Customizing the AutoCAD interface can enhance your user experience. Here are some tips. Toolbars. You can create and customize toolbars by using the CUI command. Drag and drop commands to create a toolbar that suits your workflow. Workspace. Save custom workspace settings to switch between different layouts quickly. Use the workspace command to create or modify workspaces. Command aliases. You can create command aliases, shortcuts, for your most used commands. This can be done by editing the Academy PGP file located in the AutoCAD support folder. Custom line types. Create your own line types by defining them in the line type file, .lin. This allows for greater flexibility in your designs. 13.3 Productivity enhancements. To further improve your productivity, consider the following enhancements. Dynamic input. Enable dynamic input, F12, to display command prompts near the cursor, making it easier to input values without looking at the command line. Quick Access Toolbar. Customize the Quick Access toolbar with the commands you use most frequently for easy access. Selection Cycling. Enable selection cycling, Ctrl plus click, to quickly toggle between overlapping objects when selecting. Batch Plotting. Use the Publish command to batch plot multiple drawings at once, saving time on printing. Sheet Sets. Organize your drawings into sheet sets to manage larger projects more efficiently. 13.4 Time-saving techniques. Here are some techniques to save time while working in AutoCAD. 39 PAGE, Templates. Create and use templates for new drawings to ensure consistency and save setup time. Layers. Use layers effectively by creating a naming convention and utilizing layer states to quickly switch between different visibility setups. Blocks. Create and use blocks for repetitive elements in your drawings. This not only saves time but also keeps your drawings organized. External references. Ecrefs. Use Ecrefs to manage large projects by linking to external drawings instead of copying them into your current drawing. Parametric constraints. Apply parametric constraints to maintain relationships between objects, allowing for easy adjustments later on. 13.5 Learning resources. Continuous learning is essential for mastering AutoCAD. Here are some valuable resources. Official Autodesk training. Check out Autodesk's official training programs and webinars for comprehensive learning. Online courses. Websites like Udemy, LinkedIn Learning, and Coursera offer various AutoCAD courses, ranging from beginner to advanced levels. YouTube tutorials. Many talented creators share useful AutoCAD tutorials on YouTube, covering specific tools and techniques. Forums and communities. Engage with the AutoCAD community on forums like CAD Tutor and the Autodesk community to ask questions and share knowledge. Books. Consider reading books like AutoCAD for Dummies or Mastering AutoCAD for in-depth insights and tips. By implementing these tips and tricks, you can enhance your AutoCAD experience, making your design process more efficient and effective. Happy drafting! 40 PAGE Chapter 14, The Future of AutoCAD. As we look ahead, the landscape of computer-aided design, CAD, continues to evolve rapidly. This chapter explores the key trends shaping the future of AutoCAD, the influence of artificial intelligence and automation, anticipated updates, strategies for preparing for future versions, and the importance of ongoing education and certifications in this dynamic field. 14.1 Trends in CAD technology. The CAD industry is witnessing several transformative trends, including cloud-based solutions. Increasingly, CAD software is moving to cloud platforms, allowing for real-time collaboration, remote access, and enhanced storage capabilities. This shift facilitates teamwork across distances and improves project management. Integration with other technologies. CAD is becoming more intertwined with other technologies such as building information modeling, BIM, geographic information systems, GIS, and virtual reality, VR. This integration allows for more comprehensive design solutions and better visualization. Customization and flexibility. Users are demanding more customizable interfaces and tools that adapt to their specific workflows. Future versions of AutoCAD are expected to offer enhanced customization options, allowing users to tailor their environments to suit their needs. Sustainability. As environmental concerns rise, CAD technology is increasingly focused on sustainable design practices. New tools and features aimed at energy efficiency, material optimization, and life cycle analysis are becoming essential components of the design process. 14.2 The impact of AI and automation. 41 PAGE Artificial intelligence, AI, and automation are set to revolutionize how CAD is used. Enhanced design capabilities. AI algorithms can assist in generating design options, optimizing layouts, and even predicting potential issues before they arise. By analyzing vast amounts of data, AI can suggest the most efficient design solutions. Increased efficiency. Automation features, such as automated drafting and design checks, can significantly speed up the design process, allowing designers to focus on creativity and innovation rather than repetitive tasks. Smart assistants. Future versions of AutoCAD may incorporate smart assistants that can help users navigate complex functions, provide design suggestions, and streamline workflows through voice commands and natural language processing. 14.3 Future updates and features. As AutoCAD evolves, several updates and features are expected to enhance user experience. Improved user interface. Continuous improvements to the user interface will focus on making tools more accessible and intuitive, enabling users to work more efficiently. Advanced collaboration tools. Future versions will likely include enhanced collaboration tools that facilitate teamwork, including real-time editing and integrated communication features. Augmented reality, AR, integration. As AR technology matures, integration with AutoCAD could allow designers to visualize their designs in real-world settings, providing immediate context and feedback. Expanded file compatibility. As the diversity of design tools increases, AutoCAD is expected to improve compatibility with a wider range of file formats and software, making it easier to work within multidisciplinary teams. 42 PAGE 14.4 Preparing for future versions. To stay ahead in the evolving CAD landscape, users should consider the following strategies. Stay informed, regularly follow industry news, AutoCAD updates, and webinars to keep abreast of new features and best practices. Explore beta programs. Participating in beta programs for upcoming releases can provide early access to new features and the opportunity to influence the development of the software. Adapt to change. Embrace new tools and workflows as they emerge. Flexibility and a willingness to learn will be crucial in adapting to future versions of AutoCAD. 14.5 Continuing education and certifications. As technology advances, so does the need for ongoing education and professional development. Online courses and tutorials. Many platforms offer online courses that cover the latest features and best practices in AutoCAD. Engaging with these resources can enhance skills and keep knowledge up to date. Certifications. Obtaining certifications, such as Autodesk Certified Professional, can validate expertise and improve job prospects. These certifications often require ongoing education to maintain, ensuring that professionals stay current in their knowledge and skills. Networking and community engagement. Joining professional organizations, forums, and user groups can provide valuable insights and support from peers, enhancing learning opportunities and professional growth. 43 PAGE. In conclusion, the future of AutoCAD is bright, driven by technological advancements and a focus on collaboration, efficiency, and sustainability. By staying informed and proactive, designers can leverage these changes to enhance their work and remain competitive in the ever-evolving CAD landscape. Conclusion about AutoCAD. Summary of key concepts. AutoCAD is a powerful and versatile computer-aided design, CAD, software widely used across various industries, including architecture, engineering, and construction. Key concepts include 1. 2D and 3D design. AutoCAD allows users to create detailed 2D drawings and complex 3D models, making it suitable for a range of applications from drafting floor plans to designing intricate mechanical components. 2. Precision and accuracy. The software is built for precision, enabling users to create designs with exact measurements, which is crucial in professional settings where specifications are paramount. 3. Layer management. Layers in AutoCAD help organize different elements of a drawing, allowing for better clarity and control over the visibility and properties of various components. 4. Annotations and documentation. AutoCAD provides tools for adding dimensions, notes, and other annotations to drawings, ensuring that designs are not only visually appealing but also informative. 5. Customization and automation. Users can customize the interface and automate repetitive tasks using scripts and macros, enhancing productivity and workflow efficiency. 6. Collaboration and sharing. AutoCAD supports collaboration through features that allow multiple users to work on the same project and share designs in various formats, facilitating teamwork across different locations. 44. PAGE encouragement for continued learning. The field of design and drafting is continually evolving, and so is AutoCAD. To stay competitive and make the most of this powerful software, ongoing education is essential. Here are some ways to continue your learning journey: online courses and tutorials. Numerous platforms offer courses that cover beginner to advanced AutoCAD techniques. Look for accredited programs or reputable instructors. Practice projects. Apply what you've learned by working on personal or professional projects. Real-world application of skills solidifies knowledge. Join user communities. Engaging with fellow AutoCAD users through forums, social media groups, or local meetups can provide support, tips, and inspiration. Stay updated. Keep an eye on updates and new features released by Autodesk. Familiarizing yourself with the latest tools can give you a competitive edge. Explore related software. Learning complementary software, such as Revit for building information modeling, BIM, or other CAD tools, can broaden your skill set and enhance your versatility in the industry. By embracing a mindset of continuous learning, you can enhance your proficiency in AutoCAD and expand your career opportunities in the ever-evolving world of design and engineering. Appendices A. Glossary of terms. CAD, computer-aided design software used for creating, modifying, analyzing, or optimizing a design. Layer, a way of organizing different elements of a drawing for better management and visibility. 45. PAGE, viewport, a window in the AutoCAD workspace that displays a view of the drawing area. Dimensioning, the process of measuring and annotating drawings to convey specific sizes and locations. B. Keyboard shortcuts. L. Line, C. Circle, PL, polyline, rec, rectangle, TR, trim, X, extend, M, move, CO, copy, ZO, zoom extents, D. Dimension. C. Further reading and resources, official AutoCAD documentation. Access comprehensive guides and tutorials on the Autodesk website. AutoCAD User Guide, a detailed manual often included with the software. YouTube channels. Many creators offer walkthroughs and tips for mastering AutoCAD. Books. Titles such as AutoCAD for Dummies or Mastering AutoCAD provide in-depth knowledge and practical exercises. Online forums. Sites like Reddit or CAD Tutor offer community support and advice from experienced users. By utilizing these resources and remaining engaged in your learning, you can navigate the complexities of AutoCAD with confidence and skill. 46. PAGE,